Welcome all of you. Our today's topic will be differentiability. Okay, so already we have gone through the topic continuity. That means a function is continuous if we can draw the graph of that one without any broken part and without any jumping. Okay, if it's a straight or a continuous part. But the today's topic will be different. It is differentiability. That means the functions which are continuous, we are going a step ahead. First we have checked existence of limit and then continuity of a function, and then we are going to the differentiability of a function. That means differentiability is only possible for such functions which are existing and which are continuous. Okay, which are continuous. That means I can conclude the statement that the functions which we are going to see the differentiability, they are definitely a continuous functions. Okay, every differentiable function must be continuous, but it not be necessary. In the examples we will see every continuous function is differentiable. Okay, but every differentiable function has to be continuous function. So we'll consider a function. Let us consider a function y equal to fx, which is continuous, Let's see the curve part. Suppose there is a point P, Q and R, where point P and Q are in the very close vicinity of point P. That means Q and R are very close to point P. You can say at an infinitely small distance. Okay, if you can make a chord, first we'll write the coordinates. The x value is C and the y value is f of C. You know now y fx, because y equal to fx, so it is this will be C plus h, the x value, and f C plus h. This will be C minus h and f of C minus h. Okay. First we'll find the slope of chord PQ. We know how to find the slope. Slope is changing by changing the value of x. We mean to write, then we should write it. Change in y-axis by changing x-axis. So change in y2 minus y1. So f of C plus h minus f of C by C plus h minus C. That is f of C plus h minus f of C by h. Okay, we got the slope of PQ. Now we'll find slope of PR. Should I write directly? Should I write directly? It is easy for me. PR. So it is f of C minus h minus f of C by C minus h, because C minus h minus C. Okay. So what we get the value here? F of C minus h minus f of C, f of C by minus h. Now you know what this h is. Okay, when h tends to 0, we can write a line here. When h tends to 0, R and Q tends to P. That means that these two points are nothing but they are same, and therefore when h tends to h tends to 0, then obviously P and Q tends to the point P, Therefore, the slope of this chord is equal to this chord because they are very close. So these are not two different lines, but this is one same line. And if you consider them as one same line, then you see at the point P, you can draw a tangent. So instead of having the slope of this and this, we can directly have this is equal to the slope of this one, the slope of the tangent, when it is possible. When this distance and this distance is very, very less. That means h tends to 0. Very small. Right? So we write a statement here. When h tends to 0, r and q tends to p, at that time, write a statement here. Limit h tend to 0, slope of PR is equal to limit h tend to 0, slope of PQ is equal to slope of tangent at Q. Very, very important. Okay. So we will sum up that. So what we write for this? That is limit h tend to 0, slope of this one. First we write that left hand one. So this one PR. PR. F of C minus h minus f of C by minus h is equal to limit h tend to 0, f of C plus h minus f of C by h is equal to f dash C, which is equal to limit x tends to C. This I am writing as an extra point for the existence of a limit, which is equal to fx minus f of C by x minus C. Nothing special. There are 2 points x, and in the closed vicinity there is a point C. So change in y will change in x. So basically slope of the tangent is what? Differentiation of the curve means what? What it gives? It gives the slope of the tangent. So this gives us the slope of the tangent. This part is known as left hand derivative. This part is known as right hand derivative. And this is nothing but this is equal to the slope of the tangent